Question 11. This is a ball dropped vertically and the ball bounces twice before being caught. The ball bouncing, that's this section here and this section here. The ball being caught, that signifies that the ball's velocity dropped down to zero right at the end. This signifies that the ball is falling. This signifies that the ball is falling. This signifies that the ball is rising, and this signifies that the ball is rising as well. Okay, now suggest why the downward sloping lines are parallel. So, a velocity time graph, the gradient is the acceleration. So when these lines are parallel, the gradient is the same all the way through. That signifies that the acceleration is constant, it's negative, and it is the acceleration due to gravity. Key ideas, same gradient, so acceleration is constant, and that acceleration is actually 9.81, providing there's no air resistance. Right, state the reason for the upward sloping dotted lines. So what that means, don't give any, it says state what's the, so a statement to tell us what's going on in this section here. Why is there a dotted line here? It's, what does it signify? It's the point where the ball strikes the ground, and this is when the ball is in contact with the ground. So the entire section here is when the ball is hitting the ground. It's slowing down and then changing direction and speeding up. So the ball is in contact with the ground during this period, slowing down, change direction, increasing speed. Describe how the gradient of the dotted lines would change if the basketball was not fully inflated. Now, if it wasn't fully inflated, it's going to compress more upon contact, so it's going to spend longer in contact with the ground, and therefore that from there to there, if you look horizontally, there's not much time, but if it's in contact with the ground for longer, then that point X may be somewhere down there, so the gradient is going to get less steep. Calculate the initial height which the ball fell. It's a velocity time graph, so the distance is what we need, and that's the area underneath the graph. So we know that the ball is falling and hits the ground and reaches zero speed here. So you could work out the area here. So we said that this is where the object was falling and this is where it was hitting the ground. So we could work out the area underneath the in this section here, and the height, this velocity, max velocity is halfway through 4.6 and 4.8, so that's 4.7. That entire area I'm looking at, that is, so each small square is 0.04 seconds. I've kind of got three squares and a half, so that's 3.5 squares times by 0.04, that's 0.14. Add that on to 0.4, that's 0.54 as from here to here. And then the area is a triangle, so it's half times base times perpendicular height. So half times 0.54 times 4.7, and that's 1.27 meters. Now there is room to maneuver on this, and that would range in between 1.1 and 1.4 meters. I've got something somewhere in between 1.27 meters. Okay, now the next question is show that the kinetic energy of the ball X is about 1 joule. So kinetic energy is half times mass times v squared. We've got the mass is given to us there. Do we know the speed at X? Let's have a look at the graph. X is the point where the ball just before it loses contact with the ground, and that is 2.4 meters per second. So multiplying that out, there's your 1 mark, picking 2.4, putting into the equation and getting an answer 1.152 joules, which is approximately 1 joule. Now, it says, hence calculate the height of the basketball at Y. Now, here we know that the area under the graph at Y, the height is the area underneath the graph. So we're going to work out that area there. However, it says hence. So that means use a previous answer to get to the height. Now, we know that when a ball rises, the kinetic energy converts into GPE. Now, that's what the examiner wants you to do. That's what that word hence is dictating for you to use what you had before and move forward. So, in terms of energy and not graphically. So, that's where you need to well, that's what you need to do. So the kinetic energy is converted to GPE. I've expanded out GPE as mass times gravity times height. I rearranged it. The kinetic energy that turns into GPE is 1.152 joules divided by 0.4 times 9.1, and you get 0.29 meters. Now, if you worked out the area underneath the graph, you would have got a value very close to that. That would have given you 1 mark. However, that's not going to give you the second mark. So you get the second mark for getting the answer, but you don't get the technique that was required to get there. Okay, so they are forcing you to use a different technique of energy rather than the area underneath the graph. Now, the velocity of the basketball on impact at W is greater than the velocity of impact at Z, and we can see this when the ball hits the ground, it's at 4.7 meters per second. When it leaves the ground, it's at 2.4 meters per second. Okay, so clearly it's lost some kinetic energy. Where has that kinetic energy gone? Some of that kinetic energy has been transferred to the ground as heat, therefore less kinetic energy available for moving upwards.